Okay, so this tutorial is focusing on the role of the loop of Henle in the nephron in concentrating the urine that's going to be produced from the nephron. Okay, so just a quick recap. The Bowman's capsule, remember from the last tutorial, is involved in filtering things out. The selective reabsorption happens at the PCT, and that's to get things that were filtered out, that are actually useful to the body, back into the blood. We're focusing on the loop of Henle today and its role in setting up a water potential gradient to allow the urine to be concentrated, and then that links to how water can move from the filtrate back into the body at the wall of the collecting duct. Okay, so that's a quick recap of the whole of the nephron. Let's focus in now on this bit and see what how it sets up the conditions for concentration. So here's my enlargement of the loop of Henle, and we're thinking about the filtrate going through all the way through the nephron, which is essentially a tube, and the filtrate goes through the proximal convoluted tubule down the descending limb of the loop of Henle, and then it goes back up the ascending limb of the loop of Henle. So the filtrate going down this limb and up this limb, it's going in opposite directions, which is quite important. And then it travels through the distal convoluted tubule and then eventually down into the collecting duct. And this is where water is reabsorbed across the wall of the collecting duct, and to make sure that as little water as possible is produced when you produce urine. So what's going to leave the nephron and eventually leave the kidney and be stored in the bladder is urine. Okay, so it kind of happens in stages. Stage one, we'll talk about what happens here first of all. So stage one is happening at the ascending limb. Okay, so what happens here is that ions are transported across the wall of the ascending limb and into this area here and this area here, which we're going to call the medullary tissue, because this tissue here represents cells that are part of the medulla of the kidney. So ions are actively transported and they diffuse as well. I'll show you the difference between those in a minute. Across the wall of the ascending limb. Okay, and what also happens here is that no water is being absorbed at this point here, and that's quite important. The wall of the ascending limb is impermeable to water, so water stays in the filtrate at this point anyway. Okay, so let's just see these little dots. I hope you can see them. These little dots represent my ions that are in the nephron tubule, and we've got quite a high concentration of ions here actually, so they're actually going to be able to just diffuse out here at the bottom part, and because there's not very many of them up here, that will be active transport. So let's just write that in as well. I hope you can see the tiny words. Okay, so this is ions. Yeah, ions are leaving the filtrate and they're being transported into the medullary tissue. Okay, all the way down. And you'll notice that because of the concentration difference of ions between the bottom of the loop of Henle and the top of this ascending limb, there's going to be a different concentration of ions in the medullary tissue. Anyway, whatever the difference, we'll come to that in a minute, the ions are soluble and so they will lower the water potential. and we can write that in here. This lowers the water potential in the medullary tissue. Okay, so we have a water potential is lowered here because of the ions. Now, because of that, because of the lowering of the water potential, if we just go back to the descending limb, now we've set up a water potential gradient between the inside of the nephron and the outside of the nephron, and water can now be drawn out of the descending limb, because this descending limb is permeable to water. Water can be drawn out by osmosis. Yeah, so let's write that down. In the descending limb, water diffuses out. Let's make sure that we've written in that it's the descending limb that this is happening. Out of the descending limb by osmosis. Okay, now what's important is that actually this limb is, whereas it's permeable to water, it's relatively impermeable to ions. So it's like the opposite of what's happening here. This one's permeable to ions, but impermeable to water. This one's permeable to water, but impermeable to ions. So let's write that in. So descending limb is impermeable relatively to ions. So the important thing is, so the ions stay in the filtrate. So by the time the ions are able to get out of the loop of Henle, which is at the first part of the ascending limb, there's going to be loads of them because they weren't able to leave the limb here. So there's lots and lots of ions available here to diffuse out, and that means that there are going to be very many ions in this part of the medullary tissue, and so the water potential will be very low here. Okay, and the same on the other side. The water potential is very low on this side as well. Whereas up here, relatively fewer ions, they're being actively transported out. It's still going to lower the water potential, but the water potential is not going to be so low. It's going to be lower than the filtrate. That means that water can be drawn out here, but it's not going to be as low as it is at the bottom of the loop of Henle. So let's just draw in the fact that water is leaving here all the way down the descending limb. Okay, so what we have is a really, really low water potential down here. Let's write that in as, again, very low, because of this accumulation of ions here. And we also have a low water potential up here, but it's not quite as low as it is down here. So we've got a gradient of water potential between the top of the loop of Henle, or the top of the collecting duct as it is now, and the very, very bottom of the collecting duct. So it's getting lower and lower and lower and lower as we go down the collecting duct. So let's see if we can write in something about what's happening here. Okay, so the whole point of this system is to make sure that water can be absorbed from the filtrate. We want to make sure that water is absorbed all the way down the collecting duct wall, so as much water is being recovered from the filtrate, so as little water as possible leaves in your urine. So that's achieved by, let's just write this down, the filtrate. That's the liquid that's going through the nephron, remember. The filtrate flows in the opposite directions. In the ascending limb and the collecting duct. So let's just refer back to the picture, there's the filtrate going upwards here, and there's the collecting duct going downwards. The filtrate and the collecting duct going downwards. Okay. So because of this, the filtrate in the collecting duct, let's just write that down, is always next to fluid in the medullary tissue. This is like tissue fluid, basically. So this bit here, it's always going to be next to fluid with a lower water potential. Let's write that down. With a lower water potential. Okay, so as the filtrate is going down here, water is being reabsorbed by osmosis. Important word to remember. Okay, so it can only be reabsorbed by osmosis if there is a higher water potential than there is there. Okay, and because the water potential is low here, that means water can flow in that direction from a high to a low water potential. But as the water is being lost, the water potential in the filtrate, in the collecting duct, will become lower because the water is being lost. So that means that as the filtrate goes down, it always needs the bit of tissue on the next to it to have an even lower water potential. So as the water potential goes down and down and down and down inside the filtrate, inside the collecting duct, it has to be next to the medullary tissue, which has got an even lower water potential. So water always gets absorbed from a high to a low water potential all the way down the collecting duct. So let's write that down. So water passes into the medullary tissue from the collecting duct by osmosis, really good word to use, along the whole length of the collecting duct. So this multiplication of the water potential is getting lower and lower and lower. We call this the counter current multiplier. And let's just recap. Okay, so this happens because ions move out of the ascending limb. The water moves out of the descending limb, leaving behind lots of ions which can continue to be transported out of the ascending limb. We have a situation where there are far more ions at the bottom of the loop of Henle, and so a much, much lower water potential. There are far fewer ions at the top of the loop of Henle, and so the water potential is a little bit higher. It's still low, but it's higher than it is at the bottom here. So as the filtrate travels down the collecting duct, water gets absorbed by osmosis, but it always gets absorbed from a higher to a lower water potential all the way down the collecting duct. So what happens in the end is that you get a urine which has as little water in it as possible. So the water that's being recovered is going eventually back into your circulation.